You've probably seen airplanes soar to jaw-dropping heights, but could we push them even higher? Maybe into space? Well, the short answer is no. Regular airplanes can't fly that high. But why not? What's stopping them from going higher? The truth lies in how airplanes operate through air versus space, and the answer may be more fascinating than you might think. But here's the twist. While most planes can't, a special kind of aircraft can. Stick around to discover what it is and how it could change space travel. Commercial jets typically operate at altitudes between 28,000 and 35,000 feet, or about 8,534 and 10,668 meters, with occasional altitudes reaching up to 40,000 feet, or about 12,192 meters. But exceptions, like the Concorde, exist. This supersonic jet could reach 60,000 feet, or 18,288 meters, far beyond typical limits. To understand why airplanes can't escape Earth's atmosphere, we first need to understand the four primary forces of flight: lift, weight, thrust, and drag. Planes are designed with these forces in mind, which are essential to a successful flight. So here's how flying works. When the lift is greater than the weight, the plane goes up. If the lift falls short, it's heading down. Now, when thrust beats drag, the plane speeds up. But if thrust isn't cutting it, you're slowing down. And when everything's perfectly balanced, lift equals weight, thrust equals drag, you're cruising along straight and level. No speed changes, just smooth sailing. Simple, right? We've just learned about the forces that keep airplanes in flight. But understanding how these forces work is crucial because airplanes primarily fly through the Earth's atmosphere. So let's break it down. Air is what makes lift possible. Airplanes take to the skies by pushing air upwards with their wings. These wings are specially shaped to make the air rush faster over the top than underneath, creating a pressure difference that lifts the plane into the sky. But here's the catch. As the plane climbs higher, the air gets thinner, which means it has to fly faster to generate that all-important lift. Now, here's where things get really interesting. Space is a whole different ballgame. It's a vacuum, no air to speak of, so there's nothing to provide lift for the plane. Without air, those wings can't do their magic, and that's why regular airplanes can't venture into space. To fully understand this, let's explore first the different layers of the atmosphere that affect flight. Earth's atmosphere is divided into 5 layers based on temperature and composition: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere is the lowest layer, containing 75–80% of the atmosphere's mass, while the exosphere is the highest layer with the lowest gas density. Now, where exactly does space begin? That's where the Kármán line comes in. Sitting at roughly 62 miles, or about 100 kilometers above sea level, this internationally recognized boundary marks the point where the atmosphere becomes so thin it resembles the vacuum of space. Spacecraft must reach much higher speeds than airplanes to overcome Earth's gravity and enter orbit, leaving our atmosphere behind. So, are you ready to find out what it takes to launch into space? Or how planes beat gravity? If you're nodding your head, you're definitely in the right spot. Stick around as we dive deeper into these mind-blowing topics. And if you're enjoying this cosmic ride, just make sure to give us a thumbs up, subscribe, and smash that notification bell. Trust me, we've got a ton of exciting content coming your way that you won't want to miss. At high altitudes, thin air becomes a challenge for airplanes in a critical flight region known as the Coffin Corner, where two limits come into play: stall speed and the essential Mach number. In thin air, the air can't move as fast, slowing the plane. If the plane goes too slow, it won't get enough lift to stay airborne. The slowest speed a plane can fly without falling or stalling is called its stall speed. Now, airplanes also have a speed limit called the Mach number, which tells us how fast something moves compared to the speed of sound. As a plane approaches the speed of sound at high altitude, the thin air becomes bumpy and unpredictable. This bumpiness can mess with the lift on the wings and make the plane hard to control. In the Coffin Corner, pilots must be careful with their speed. If they go too slow, they might stall and fall. If they go too fast, the bumpy air could cause them to lose control. At this point, the aircraft must descend while carefully increasing speed in a controlled manner to prevent a potential crash. Commercial airplane engines need to be more powerful in order to launch aircraft into space, as they only generate about 63,000 pounds, or 31.5 tons of thrust, while a space launch requires approximately 7.2 million pounds, or about 3.6 thousand tons of thrust. That's more than 10 times the normal airplane engine. Also, airplane engines need air for combustion, so insufficient air supply leads to engine failure. So the air component in airplane is essential when considering space travel, since it is a place without much air. But what if a pilot dared to defy the odds and attempted to fly their plane into space despite the risks? Like the Greek myth of Icarus, who disobeyed his father and soared higher with wax wings until the sun's heat caused them to melt. Such a pilot would inevitably face a disastrous descent back to Earth. Now that we've uncovered the secrets of how regular planes work and why they can't reach space, it's time to shift gears. Let's talk about something that can actually break through that sky-high ceiling: space planes. Okay, quick pause. Here's a tiny hamster chomping away on a cucumber like it's the most important thing in the world. The OG spaceplane, NASA operated the Space Shuttle from 1981 to 2011. The shuttle launched vertically similar to other rocket-propelled spacecraft, but landed as a spaceplane on a runway. This unique combination of rocket launch and airplane landing made the Space Shuttle a groundbreaking step toward the future of space travel. In response to NASA's Space Shuttle, the Soviet Union initiated the Buran program. Buran-class spacecraft resembled the Space Shuttle, but had some slight design differences. Unlike the shuttle, its main engines didn't go into orbit. Small rocket engines on the craft's body aided its ascent, and it could land fully autonomously and perform uncrewed missions. Like the shuttle, Buran took off like a typical spacecraft, but landed like a plane on a runway, blending rocket power with airplane-style landings. Then came the Boeing X-37, or the Orbital Test Vehicle, is a reusable robotic spacecraft first used in 2010. Designed to launch into space via a rocket, re-enter Earth's atmosphere, and return to the ground as a spaceplane. The US Space Force used it for covert operations. And Boeing's X-37B spaceplane launched its 7th mission on May 17, 2020, operated by the US Air Force. As an autonomous spacecraft, it tested and validated future space mission technologies. Now, let's shift gears and dive into the world of Sierra Space, a company pushing the boundaries of what's possible in space travel. Known for its innovative approach, Sierra Space is making waves in the aerospace industry with its commitment to building the future of space exploration. And at the forefront of their groundbreaking projects is the Dream Chaser, nicknamed Tenacity. This sleek spaceship, which looks like it jumped straight out of Star Wars, was gearing up for its much-anticipated debut flight to the ISS, now targeted for September 2025. What's the hold-up, you ask? Well, it's all about ensuring that Tenacity is 100% ready to handle the wild ride of launch and landing. After passing some grueling tests, they wanted to make absolutely sure everything was perfect before sending it off. Under a NASA contract, Dream Chaser is scheduled for 7 cargo resupply missions to the ISS, offering a reusable alternative to SpaceX's Dragon capsule. It will launch atop a United Launch Alliance Vulcan Centaur rocket, just like your typical rocket launches. Unlike Dragon, however, which splashes in the ocean after re-entry, Dream Chaser can glide back through the atmosphere and land on a runway at least 3,048 meters, or 10,000 feet long. After exploring the innovative capabilities of Sierra Space's Dream Chaser, let's shift our focus to another exciting player in the reusable spacecraft game, Shenlong. China's first reusable spacecraft had its inaugural orbital mission on September 4th, 2020. It's said to be reusable up to 20 times, launched vertically within rocket fairings, and autonomously lands on runways, similar to an aircraft. Seen as a significant leap in China's space endeavors, Shenlong is speculated to contribute to the country's space military strategies. Compared to the US-operated Boeing X-37B, it's anticipated to impact China's space capabilities significantly. But wait, there's more. While we're talking about those orbiting spaceplanes, let's not forget the rocket-powered heroes that blasted their way through the Kármán line, the X-15 and Spaceship One. Let's take a trip back to July 19th, 1963. Picture this. Astronaut Joseph A. Walker climbs aboard NASA's X-15 for Flight 90, and bam! He shoots up to a jaw-dropping 349,450 feet. That's about 106.01 kilometers. For 3 to 5 glorious minutes, he floated in weightlessness as he entered the thermosphere, feeling like a true space explorer. But it's not all fun and games. During re-entry, some parts of the craft heated up to a sizzling 1,202 degrees Fahrenheit, or a spicy 650 degrees Celsius. And get this, the whole adventure was short, sweet, and out of this world as it wrapped up in just 12 minutes. Then, back in 2004, a spaceplane called Spaceship One made history for being the first private ride to space, funded by no government, but an adventurous businessman. The challenge? Build a reusable spaceship that could reach way up, over 100 kilometers high, and do it twice within 2 weeks. The big prize, $10 million. What made Spaceship One special was its clever re-entry system, nicknamed the Feather, because similar to a bird folding its wings to slow down for landing, Spaceship One did the same thing. Tilting its wings and tail way out of line created a ton of drag, slowing it down safely without needing the pilot to do too much. After that fiery descent, the Feather folded back for a smooth glide landing. This whole trip was quite the ride for the pilot, super fast and pulling over 4 Gs for a bit, which is like feeling 4 times your weight. Spaceship One is a museum piece today, but it played a big role in opening up space travel to private companies.
After Spaceship One claimed the Ansari X Prize, famous entrepreneur Sir Richard Branson of the United Kingdom stepped forward and formed a company called Virgin Galactic. He sees himself offering space transportation for tourists in a larger version of Spaceship One.
Then, in 2008, they unveiled their first carrier aircraft, White Knight II. Just over a year later, they showed off Spaceship Two, the sleek spaceship that would hitch a ride with White Knight II. Things were moving fast. By 2010, Spaceship Two, nicknamed VSS Enterprise, was up in the air for its first crewed test flight. Sadly, tragedy struck in 2014 during another test flight accident that seriously injured the pilot and killed the co-pilot. Yet, this did not stop its founder, Richard Branson, who praised the company's 400 engineers and technicians and said, "While this is a tragic setback, we are moving forward and will do so deliberately and with determination." After the setback in 2014, Virgin Galactic wasn't ready to give up on space tourism. In 2018, they were back in the air with their spaceship, VSS Unity. This time, they were pushing the limits, reaching way higher altitudes. By the end of 2019, they even broke a record at 51.4 miles, about 82.7 kilometers. Finally, in 2021, Virgin Galactic made history with their first fully crewed spaceflight. And guess who was one of the lucky passengers? Sir Richard Branson himself. He got a taste of space firsthand.
To all you kids down there, I was once a child with a dream, looking up to the stars. Now I'm an adult in a spaceship with lots of other wonderful adults looking down to our beautiful, beautiful Earth. To the next generation of dreamers, if we can do this, just imagine what you can do.
Virgin Galactic launched its first commercial spaceflight, Galactic 01, on June 29, 2023. 3 members from the Italian Air Force and the National Research Council of Italy were on board. The 90-minute trip gave them a few minutes of weightlessness at its peak. While floating around, the crew performed 13 experiments investigating biomedicine, fluid dynamics, and new materials in microgravity using cool gadgets like wearable sensors. So, back to snagging a seat on Virgin Galactic's spaceplane. First off, tickets were about $450,000 each. It's steep, we know, so primarily the top 1% can swing it. But keep watching, and we'll let you in on the secret of the other ways to get that ticket to space. That other way, join a fundraising contest. That happened to Keisha Shahaf, her daughter Anastasia Mayers, and John Goodwin, who won a Space for Humanity contest ticket and flew on the VSS Unity in August 2023. Commander Beth Moses joined them.
I'm still up there, and it's just amazing that you can land so smoothly on the runway coming back from space. That was the most amazing. I mean, looking at Earth was the most amazing, but knowing that, you know, you don't have to come pick me up in the middle of the desert somewhere because the parachute landed wherever. But it was so comfortable. It was really the best ride ever.
Got space fever? You're not alone. If today's journey has you craving more cosmic adventures, you won't want to miss what's next. We're shifting gears to explore Polaris Dawn, the thrilling mission that just launched on September the 10th, 2024, making history with the highest altitude ever reached by a crewed spacecraft. Trust me, What we cover next is crucial for understanding the bigger picture of commercial spaceflight. So don't miss out. Hit that play button to join us on this exciting adventure.